Hello, I'm Mr. McBrien. This is TIJ10, Arduino 2, Programming Basics. So yesterday we talked about the Arduino. We threw together our first Arduino sketch, talked about what makes it special. Today we want to look at how to build our own devices, how to configure the system to Today, we're going to start to learn how to create our own devices. So, we need to get through some of the basics of Arduino programming. We're going to talk about single and looped commands, we're going to talk about how to comment our sketches, and we're going to talk about the outputs that make the Arduino so special, that are so hard to achieve with a personal computer. So, in a given device program, there are lots of commands that are done once. These are typically setup type commands. We might declare variables, we might open communication, we might in some cases move things to their starting positions before we begin our work. However, most devices execute commands multiple times, and Arduino is set up by default to do this, to execute commands over and over again in what we call a loop, and keep doing this until there's some reason to stop. We already saw this with a blinking LED, but we can see this with lots of other things like monitoring inputs and things like this. So how do we achieve these things? Well, when we're putting together a sketch, we'll identify what we want to run once, and we'll identify what needs to be done over and over and over again. The things that are done once are typically put in what we call the setup. And this is a routine that executes right at the beginning of the sketch. So we'll put those in those curly brackets after void setup. In contrast, the things that need to be done over and over again, we can put into the loop, put into the curly brackets that comes after the loop. Okay, so now we know some basics about the structure of the sketch. Before we go any further, we have to deal with this problem of commenting. So, sketches might be something we create today and never look at again, at least in TIJ. But for normal programmers, for commercial programmers, programs tend to have a lifetime. In some cases, code that is created is reviewed by different people as much as 10 years after it was originally created. And so we have this thing called commenting. This is a way for programmers to include information for future reviewers to look at. These comments are ignored when the program is put into its final form, when it's compiled. They don't change the way the program executes at all, but when programmers are reviewing the code, these comments are extremely important. They can let you follow the purpose of why the code exists and see why you did something at a later point. Now, believe it or not, these aren't just for programmers to communicate with other people. Programmers also review their own code at a later point, and you'd be surprised how little they remember of why they created what they did. In any case, there are two ways to identify comments. If we want a single line comment, we can just put 2 slashes and put the information there. We can also identify a multi-line comment, and the /* approach is described in your notes. So when it comes to the sketches that we're going to submit in TIJ, we must appropriately comment all of that code. This means identifying any major subroutines, any groups of code and their purpose. It also means we're going to put a header at the start of the sketch that contains your name, the date, and the name of your sketch, so it's easy to identify why this code exists. And again, make sure you don't need to label every line of your code, but major subroutines, major groups of lines should be labeled with some words about their purpose. And if you want highest marks, if you want to use good programming practices, you need to get good at making comments. Now, this may seem a little bit difficult to understand at this stage, but one of the things that programmers need to do all the time is to effectively delete portions of their code to try to figure out what's going on with other portions. Now, you actually don't need to do this when you're doing this debugging step. There is a special tool inside the Arduino IDE to allow you to highlight text, right-click, and tell the IDE that you want these lines to become comments. And it'll introduce the slashes necessary for this. When you're done the debugging step, you can highlight this code again and simply right-click and choose uncomment, and it'll strip away those lines. This is a very powerful tool for debugging your code. Okay, so we alluded to the idea that Arduinos have special power in terms of being able to control electronic devices directly and without needing things like drivers. So the Arduino has two kinds of pins, digital and analog pins. We'll deal with the analog pins some other time. We're going to talk about the digital pins right now. And these digital pins, when we turn them on in our code, they will output 5 volts. And unsurprisingly, when they're off, they output 0 volts. So this gives us the capacity to, in a very simple sketch, control devices, send a potential to a given device. And that's what we saw yesterday when we were doing our blink sketch. So it's pretty simple to put together. All we have to do is use a declaration. So we declare our pins at the start with this pin mode command. In this case, this pin mode command is saying that pin 9 is going to be used for output. You can notice that LED pin is 9 up above. In fact, this is an extra step you don't have to do. Most sketches include this idea of assigning a variable to that pin. You don't need to do that. This could also be pin mode 9, output. So pin 9 has just been now configured as an output. If you look at your code yesterday, you should be able to find similar lines associated with your code. And this is one of the most important Arduino skills, the capacity to declare a pin as an input or an output so that you can use it in future parts of the sketch. Again, this pin mode command will declare a pin as output or input. We'll talk about input at another point. So our example that I gave in the last slide, pin mode 9, output, declares pin 9 as an output pin. Wow, I can read a slide. Now if we want to send a 5-volt signal to that pin, all we have to do is use a digital write command. So an example of this, if we want to turn off our pin 9, we would send digital write 9, low, turning off pin 9. No great shock, if we want to turn it on, we'd send digital write 9, high. So what you can do now, if you think you're ready, is modify your blink sketch from yesterday. Set up a breadboard with a 1000 ohm resistor. Don't forget to protect your LED, and you can go ahead and light that LED. Now, there is a trick here, and it's something important. To have a circuit, we have to return the current back to the power source. The power source in this case is the Arduino. You've got to remember to connect your breadboard's ground to the Arduino GND pin, and there are several of those on the Arduino. So you can connect your LED resistor combination to pin 9 if you want to use pin 9 from your sketch, and connect the ground to the Arduino ground. And you can go ahead and modify your sketch to light pin 9's LED rather than the onboard pin 13. Once again, I'm going to emphasize, because so many students have a problem with this, you must ground your device in order for the Arduino to be able to power it. Okay, and here's what it looks like. You can see the GND pin connected to the ground on the breadboard. Now in this case we've connected 5 volts to the breadboard. Sometimes you won't need this wire at all if you're simply controlling these things. Okay, key points for today then. We declare any pins we want to use as input or output using the pin mode command. We have to remember to ground the Arduino and the breadboard. They need to have a shared ground. We need to remember that if we want to get high marks, if we want to use good programming practices, we have to use excellent commenting. So the way that we declare pins is using the pin mode command. The way that we send a potential to these pins is through the digital write command. Okay, and the homework for today, there's a Dropbox assignment involving setups and loops. Go ahead and look at that. These references should help you. They cover the various things that we talked about today. Thanks very much, and have a great night.